Okay, now we are in our last section of section 8, and we will be doing the application of purchasing insurance. The customer theory with risk provide a good building block for economic models involving risk sharing, risk diversification, and risk management. So we will be looking at one of them, which is the purchasing insurance, because I'm not sure that at some point in your life, every one of you have to make this kind of decision, whether or not to purchase insurance, and if you do choose to purchase insurance, what the level of coverage of insurance that you choose to purchase. Let's consider a risk-averse consumer who hate risk, and that he has a war nomen and Morgenstern utility function U, right? And there are two possible states. The state one, no accident. There is an accident with the probability pi, and the state two, no accident with the probability 1 minus pi. And this consumer has an initial wealth of the bill, which is certain. And if there exists an accident, it will bring a loss of L, where L would be smaller than the bill, which means that if you have an accident, right, in state one, if you have an accident, then you end up with this amount of wealth instead of the bill. When you start with the bill at the beginning, and then if you end up with state one, you have less wealth. If you end up with state two, when there is no accident, then you keep the same level of initial wealth. Nothing happens, right? In the same way. And now this consumer thinking about purchasing insurance. Let's say that we assume that purchasing X units of insurance means that she will be paid X dollars in the case of accident. So each unit of insurance costs P dollars. This P dollar is a fraction between 0 and 1, right? So each unit of X costs P dollar. So the insurance premium that this consumer has to pay is P times X. P is a fraction less than 1. X is a dollar. So P times X would be smaller than X, right? And this insurance premium must be paid regardless of accident or not. For convenience, we also allow her to purchase a negative insurance where X could be negative value, but this really does not matter for our analysis. So let's look at this state contingency consumption. We have C1, an accident consumption when there is an accident, and state 2 consumption when there is no accident. So this 45-degree lines represent C1 equal to C2, or the wealth in both states are the same, or there is a certainty, right? So if we start with the 45-degree line, so we have the bill, right? The bill, the same. And then we move to the left. By moving to the left, we know that this point, by moving to the left by L dollars, that means that at that point, we have the bill less L dollar in state 1, and the bill dollars in state 2 when there is no accident, right? And that is our endowment that we start with, right? We will start with, okay, this is our C1, C2, two mutually exclusive wealth. Either I end up with the bill less L consumption in the case of accident, or I end up with the bill if I don't have an accident, right? And that is my endowment point E right here. And I want to develop the budget line. So I have to think about the option of buying insurance. So I know that this endowment is affordable, right? Because I could just choose not to buy insurance. If I don't buy insurance, I will end up with this bundle, like this possible consumption content state contingent consumption set, but I also can choose to buy insurance. Now, if I choose to buy insurance, then that would actually give me some sort of, okay, if I choose to buy insurance, what is going to happen? What is going to affect my wealth in each state if I do choose to buy insurance, right? How does it move from point A, for example? Then let's say that if I buy 1 unit of insurance, I know that if I buy 1 unit of insurance, that means that I will have, in the case of no accident, right? If I buy insurance, it has to be affordable, right? If I buy insurance, then in state 1, when there is an accident, and you have an accident, what would happen with your wealth? And when you do not have accident, what happened to your wealth? Let me just do it a little bit. Maybe somewhere here. Okay. With insurance, right? If you, okay, make easier to start with no accident. With insurance, if there is no accident, then you will actually lose the wealth by P dollars. Let's say that we just look at the only 1 unit of insurance, right? So if you have no insurance, then your W2 is equals to W less P, right? You will lose the bill by P dollars because you paid for the insurance, but you didn't need to claim for it because you don't have an accident, but you paid the insurance for P dollars. So your wealth would decrease by P dollars, right? So you're moving down by P dollars here, right? The bill minus P in the case of no accident. So the bill 2 would equal to the bill minus P. If you had an accident, then your bill 1 would be, of course, you already paid for the insurance, right? So you will end up with this. With an accident, you will actually be compensated. So you will be less L because of the accident, but then you are compensated by 1. And 1 here, why compensated by 1? Because you buy 1 unit of insurance. So in this case, X is equal to 1. It should be plus X. So plus 1. So the change from point A would be, the difference would be 1 less P, right? That is the change in the wealth in state 1, which is 1 minus P. Okay, from point A, which is from the bill less L. Now you pay the insurance, the price, the cost of 1 unit of insurance, and you are compensated. You are paid out by 1 unit of X, like $1 of X, and that is how how your state contingent consumption sets move from point E to something like this point with the insurance. Okay, and that is your budget set, where the slope is equal to this negative slope. So you can see that it would pass through point E, because point E is your endowment. It must be affordable, and also since whatever this is also affordable when you buy insurance. So let's say you buy 1 unit of insurance, right? It's gonna be like this. If you buy 10 units of insurance, you will end up like this. If you buy 50 units of insurance, you can end up like this. So that's why your budget line gonna be something like that. Okay. Or you can put PX times X, right? So to make it more general, so this slope would be, the slope is equal to negative Px over 1 minus P times X. Just more natural, more more general, so depending on the amount of X, right? But in any case, all of this should give you the budget set, the affordability of the state contingent consumption set. Okay. Next is the indifference curves. The insurance indifference curves for the insurance. So remember that along in, I don't know, in maybe in part 2 or part 3, when we talk about the marginal rate of substitution along the 45-degree line, you still remember it has to be constant, equal to minus pi over 1 minus pi. So regardless of which point it is always constant, right? So if you draw the indifference curve, any state contingency bundle along this line would have MRS on the slope of the indifference curve equal to exactly that, right? But if it's somewhere like point E, then it's going to be different, right? Or to naturally more general, MRS C1 C2 is equal to minus pi times U prime C1 over 1 minus pi times U prime C2, right? But along 45-degree line, UC1 is equal to UC2, and that's why we end up with only this. Okay. So insurance is actually really fair if the insurance premium is the expected value of the insurance. So in our case, the expected value of the insurance is pi times X. The insurance premium is P times X, right? The expected value of the insurance, right? So this pi, remember pi is the probability of having an accident or the probability that you will claim for the accident. P is the price per unit of insurance. So it would be a fair insurance if P is equal to pi. That the cost per unit of insurance is equal to the probability that you will claim for the insurance. So therefore, if we set P equal to pi, right, because of the fair insurance, so we know that P must be equal to pi. As a result, the slope of your budget line would be equal to negative pi over 1 minus pi, right? It's replace P with pi since they are equal due to the insurance being fair. And you know that the MRS, the bundle along this curve, has MRS equal to that. So the optimal would be exactly the tangency condition, right? Which is W less pi times L and W less pi times L. That is a certainty. Full insurance when insurance is fair. That a risk-averse consumer will fully insure when insurance is actually fair. It's a very general result. Like if you're risk-averse and the insurance is fair, then you will definitely fully insure. But it does not depend on how risk-averse the consumer is or how big is the loss. So it doesn't depend on how big is the loss, how big is L, or how much they had risk. It just say that, okay, if you're risk-averse, doesn't matter, you are very highly risk-averse or a little bit of risk-averse. As long as the insurance is fair, then you will choose, a risk-averse consumer will always choose fully insure. For your thought, what if the insurance is unfair in favor of the insurance company, or when the cost of the insurance per unit is actually higher than the probability of accident to occur? Will the consumer underinsure or choose X less than the amount of loss? or they would choose to over-insure X greater than the amount of loss, or fully insure when they choose the level of coverage equal to exactly the amount of loss that would have cost them if there is an accident. It's something for you to think about. In summary, in this lecture, we learned about the state contingent consumption, expected utility, and the risk reward. So it is like the approach for this lecture is quite different than the other lectures that you may have previously learned, but you can see that there are actually some similarities and some applications that you can use your previous knowledge and then adapt it or apply it to the von Neumann and Morgenstern utility function. And I hope that you more or less get a general idea of this and not be too scared of it. And hope to see you again next video for next week. Bye bye.